All right. So, we got to go over the exam first, right? All right. So for starters, it's my usual thing. So my policy is if you do better on the final exam than you did on the midterm, I'll replace your midterm exam score with whatever you get on the final. Not the other way around though. So if you had a high score in the midterm, you don't get to just ride that into the final, but you can fix a bad midterm exam score with a good performance in the final. Final will have 10 questions, each worth 10 points. All short answer essay type things, no true false, no multiple choice. There'll be at least one, if not two, conversion questions, just like on the first one. So be able to convert between the bases. Also be able to convert between data sizes. So, some number of gigabytes equals how many kilobits, that kind of stuff. Um, uh, Make sure you pay attention to the um, uh, whether or not the conversion question I give you uses one of the tricks to shortcut. So if I have you octal to binary or binary to octal, or octal or hexadecimal to binary or binary to hexadecimal, both of those benefit from that shortcut using either 3 bits or 4 bits. That will benefit you, as opposed, if you remember from the midterm, there was the easy way and then the mind-numbing way to that one question. All right. So that will account for 1 or 2 questions on the exam. I know it was asked the last class what language. I'll ask you to write the code into the exam. I don't care, Java or C++, either one of them is fine. Not Python, not because Python's a bad language, but the structure of it doesn't really show me that you understand C type languages. So let's stick with Java or C++. You could pick. I won't ask in like the question. I won't say you have to do this one in Java or you have to do this one in C++. You just pick. Show me you can code is the punchline. All right, so flipping through the slides, I'll go through the ones before the midterm as well and show you things that I might ask again or I think are extra important that you should know. Certainly understand this concept. I don't know if I'll ask it in a direct statement, but this concept is an important thing. Probably won't ask anything about the CPU, nothing about the operating systems. Let's call it a low percent chance that I could ask something about compiling, specifically around the idea of why do we need to know about the computer architecture as well as the operating system when we're compiling something. Um, Understand the difference between a high level, low level, and machine level language. Nothing about kind of the history of Apple stuff. Probably nothing there. Make sure you're familiar with both patterns for converting, whether you're going to decimal to some other base or from base to decimal. There's 2 different patterns that you can apply to all of the different conversion processes. But if you're going from something to decimal, you use one pattern. If you're going from decimal to something else, you use a different pattern. This is that slide for the size conversion. So having this memorized, I think, would be helpful. And hopefully you see there's a very strong correlation. Everything just multiplies by 1024. And then there's just a scalar of 8 when you switch columns. I don't know how I'd ask the question around this, but I could get creative, I guess. But understand this concept that programs begin and end with main. When you run a computer program, effectively you want to go and find where is main, because that's the orchestra director, if you will. That's where everything starts, and you might deviate to different function calls and stuff, but it ultimately come back to main when it ends. I probably won't ask you to do, I think we did a hello world program, error free, blah, blah, blah in on the midterm. I probably won't ask you that again. It's a wasted question when I can ask an impossible programming question instead. Right? All right. Obviously understand variables, be able to define different variables, understand this concept that you have to type variable name and then the value, and understand the different types we've dealt with in here. So we originally had our primitive types: byte, short, int, long, char, double float, Boolean. Kind of understand the differences there. I'm not asking you to memorize kind of the sizes that, int is 32 bits. So here's the range of values that fit into an int versus these other things. Kind of understand there's that concept that different primitive types hold different size values, but I'm not going to ask you to tell me, how many, what's the smallest value that fits inside of a short or something like that. Anybody know what the answer to that is? Well, short is 16 bits, signed number. So it's negative 32,768 to positive 32,767 for 65,536 unique values, which is the same as the char primitive type in Java for mapping to Unicode, where C++ maps to ASCII. So memorize that. You don't have to know those exact numbers. But I promise you, you think about it enough times, you'll memorize those numbers. Obviously, be able to write if statements, write loops, because I'm going to ask you some coding questions that you'll have to use those tools to solve some problems. Definitely understand the concept of variable scope. I think that probably will be represented on there somewhere. Especially as we look at like this keyword and think about how do we bypass the local, like in a constructor, how do we bypass the local version of a variable name so that we can set the field this dot whatever equal to the value here. So that involves understanding that the scope of those fields is outside of the local constructor. If you're going to name your parameters for the constructor the same as your field, you have to have a way of differentiating between the most local definition of a variable, in that case, to the one you actually are referencing. And that involves this idea of scope, where we have access to things. Obviously, Boolean expressions for loops and for if statements. Be able to use the modulus operator. I could see a programming question on there that, for whatever reason, has you using that. Maybe it's something with prime numbers, or I tend to like little puzzle programming questions, on an exam, because you don't have tons of time to sit there and bang on things. So little tiny math problems that have you create. I might give you a formula and say write a function that takes in these two values and outputs the result of this formula or something like that. So be able to, and it's possible to have modulo in it. Be able to write functions, specifically understand the return type, function name, parameter list. Also for this exam, we'll get to it again. There will be a question on there dealing with static versus non-static, 100%. So you should understand that static methods, static members, so fields, whatever, are owned by the class, and they're called using the name of the class. So we define them using the static keyword. We call them using the name of the class in which they were defined, as opposed to non-static members. So non-static fields, non-static methods, we define them without using the keyword static, and we call them using an instance of the method or instance of the class in which the method or the field was defined. So definitely understand those concepts, because that will be on the test. That idea of static versus non-static and why is an important concept. All right. Again, understand this concept of functions that return a value versus functions that maybe display something. If a function does something and spits out a result of value that you can then use somewhere else, it has to have a return type other than void. If your function is just going to do some magical stuff and maybe display it to the screen or whatever, but not actually hand back a value that you can use someplace else, then it would be a void function. Understand the difference between those. Again, understand the idea of the return keyword, that it's not only used to return a value from a function. It also, probably most importantly, makes a function immediately end. So you wouldn't be able to return a value if it was a void function and you tried to return something, but you can still use the return keyword inside of a void function, because it would, it just makes the function end. Sometimes you want to just short circuit a function, just get out of Dodge. All right, so return is good for that. All right. Be able to work with strings. I do like string manipulation problems on exams. So, stuff that starts off with the empty string and builds up a string containing some stuff, reversing strings, remove all spaces from strings, remove vowels, whatever, replace every character with, two of it. So like hello would be HHEELLLLOO. Say that 10 times fast. So those kinds of problems, I like asking programming questions dealing with string manipulations. Similarly with arrays, doing something with arrays. So make sure you're comfortable with those. I would venture a guess that most of the programming questions will have you be doing something with strings or something with arrays. All right. Oh, is that the question from the midterm? Whatever. Understand pointers. I could ask you a C++ specific kind of question that talks about, when to use the arrow versus when to use the dot. Expect you to understand that. Java does not require that decision making because it's a convenience for us, but I could ask that specifically about C++. So it would be fair game for me to ask you a question like that related to one of the languages. But when you're programming your answers, you can choose the language you want to use to write the code. Hopefully you're seeing that Java and C++ are effectively first cousins, right? I mean, they have way more in common than they don't. Is that a fair statement? I mean, I know you may have run into some struggles when you're moving between the syntaxes, but I mean, you take a working C++ program, you try to compile it in Java, you're not going to have anywhere near as many errors as you should. Is the punchline. And you're going to see next semester when we take our dungeon crawler and we convert it over to Unity, which uses C#, that it's even closer. C#. I mean, it's like you just have to like lowercase a couple things or capitalize a couple things, and you're good. I think in C# string is a lowercase s, Java is an uppercase s. And that covers about 90% of it right there, the differences between those languages. Yeah, so be able to work with pointer syntax. I don't think the exam is going to be super pointer heavy, where I'm going to rely on you doing pointer tricks or something like that. for any of the programming questions, or heavily rely on you to, allocate memory for weird, tricky stuff. I typically don't write questions that try to trick you. I want you to be able to show me your understanding of the concept, not because you didn't pick up on my, bait and switch or something like that. Don't you hate when teachers do that? If they try to trick you on the exam. I mean, I've done it before accidentally. Sometimes I won't think through the question I'm asking, and I realize that it takes you down this dead end or something, and then I just give everybody a 0 and laugh. But but I don't do it maliciously. I just gain entertainment from it after the fact. Be able to pass values to functions. So understand this idea that, and actually the bigger thing, and this is related to maybe some of the questions we had with the last homework assignment, kind of understand that when you're writing functions or classes, you're really writing stuff generically, because it should work for multiple different inputs. So you're performing the same, logic, but to different inputs, therefore you might get a different result. So if you ever find yourself hard coding values really anywhere in a program, really question yourself of if you're doing this for the right reason, then maybe it's okay. But generally speaking, if you're hard coding stuff inside of a function, yeah, you're probably doing it wrong. All right. It should be highly suspicious. So be able to know how many parameters the function should take for the problem it's trying to solve, and be able to leverage those parameters. Common mistakes I see on exams, if I remember for the midterm, is, like you'll take in parameters, but then the very first lines of your function, you'll just set them equal to whatever you want them to be equal to, and then you'll solve the problem as if they were hard-coded. Write your code generically to work on whatever the inputs were. I mean, you can make, assumptions like maybe, if you take a string as a parameter, maybe you can just say, I'm going to assume there's something in the string. That way you don't have to do error checking to see if it's empty or something. I'm not really looking for that on an exam, but, don't hard code your string to, hello, and then just write 3 if statements or something like that and say, well, this works for only hello. I'm asking for generic solutions to stuff. Be able to use plus, plus, minus, minus. I probably won't ask anything about the difference between it coming before or coming after. It's important, but the way I teach tends to be, you can just avoid that by just always doing it in its own line. All right. But academically, it is important, especially if you're going to go back and look at older code. New keyword, definitely be familiar with that. We used it for creating arrays, and more recently we've been using it for creating instances of classes. So understand what that is. It's the real estate agent goes and finds memory big enough for whatever you're trying to hold, and know when to use it. As far as classes go, when you see the new keyword, you're going to see a constructor being called right after that guy, right? 100% of the time. If you're working with creating an instance of an object, the new keyword means the next piece is a constructor call. Nothing on bitwise operators. They are fun though, but you'll work with them plenty in 325 next semester. I mean, I won't ask anything about the Euclidean algorithm, but it is super important for, like, put it in your back pocket if you ever need to find the greatest common divisor, because this is one of those time complexity issues that can become sticking points. Data representation, important concept, because this is really what maybe a lot of the class has been about since the midterm, right? Looking at how can we represent things in different ways and kind of improve on what we did previously. So if you remember, we started with our fractions, looking at, well, maybe we represent a fraction as a 2-bucket array, with bucket 0 being the numerator, bucket 1 being the denominator. Then we upgraded that to a struct, where we could have a single variable type, like maybe called fraction, that had 2 components, a numerator component and a denominator component. And that's similar to dictionaries in Python if you've had some other programming experience. And then more recently, we've looked at objects, classes, as let's call it the upgrade to structs, where now it allows us to hold 0 or more pieces of information, but then also do stuff with that information by adding in functions and various ways of constructing it, that kind of stuff. All right, so structs were really our hybrid step around inventing our own variable types that let us hold more than one piece of information under a single variable. Objects took that to the next level, allowing us to also have functionality around those things and then encapsulated inside of our class. So be able to use structs. I don't know that I would necessarily have you write anything with structs on the exam. I'd call it fair game, but I would say the exam will be more focused on classes, as well as methods and string and array manipulation. So if you were really going to spend time practicing programming stuff, I think it would do you well to practice a lot of stuff working with strings and practice stuff working with like arrays of integers, that kind of stuff. You know, find the largest value in an array of integers, find the smallest value, calculate the average value, you know, that kind of stuff. I think if you were very comfortable with manipulating strings and manipulating arrays, I think you will find success in a lot of the programming questions on the exam, just based on my past. I haven't written the exam yet. Apparently, I have to write it for next week, right? So, so he failed the class because he gave me that bad news. Well, I just give everybody zeros, and that saves me a lot of time grading too.
75.
I think there's plenty of people in here who don't want me to hand them a 75 and walk, right? Although I guess you have to do the math for your grade, like, oh, 75 lets me keep where I'm at now. I'm good with that. This is a roll. What fun would that be? All right. So understand this concept of like kind of what's the weakness of structs. They can hold values, name value pairs, but they can't actually hold functionality to operate on those values. They don't have the benefit of having functions embedded in them. You know what a class is, understand the members of a class, fields, constructors, functions, understand the public, private, protected stuff, understand the difference between an instance of an object and the object and the class name itself. That comes into play when we're dealing with static versus non-static. Another thing to put a big star next to, things that I've kind of mentioned throughout the semester as like, oh, this is one of those top 5 most important things, being able to read documentation being one of them. That idea of static versus non-static, super important concept, will definitely be on the exam at least once, that concept. So be able to tell me, how do you write static methods? By putting static in front of it. How do you call static methods? Using the name of the class in which the method was defined. How do you write instance methods? Don't put static in front of them. How do you call instance methods? You need to create an instance of the class in which the method was defined, and then you use that instance to call that non-static method. Okay? Super important. There will be at least one question on that. Frankly, that concept will probably show up in at least 2 questions, one way or another. Know about the this keyword, how an object refers to itself from within itself. That'll be on there one way or another. Similarly, the super keyword, but to a lesser extent, understand that this is how an object refers to itself from within itself, and super is how an object refers to its parent from within itself, and that's related to that whole hierarchy thing of how objects are built, and all object-oriented languages have a top-level object that everything inherits from. So we talked a little bit about inheritance recently. I probably will not have inheritance represented on the exam. We just touched on it. We're going to hit it pretty hard at the beginning of next term as we flesh out our dungeon crawler thingy. but definitely know what the super keyword is. It possibly could make an appearance on there. So that's kind of this thing, how object-oriented languages are built with the hierarchies. Public, private, protected, with an emphasis for this exam being on the public versus private, since the protected is very much a inheritance connector, right? The concept of setters and getters, that we typically want to have fields be private. And then if we need to give ourselves potentially read-only access to a field, we would write a getter. A public getter lets us get the value of a field, but doesn't let us change the value of a field. Where maybe a public setter does let us change the value of a field. Then you ask the question, well, why didn't I just make it public? Well, a setter gives you then the opportunity to put some logic around whether or not you're going to update the value. Maybe you don't want a value to be any value lower than 0. So you take in the value you're updating it to, you say, if it's greater than or equal to 0, then change it. Otherwise, don't. Something like that. So a setter gives you an opportunity to interject some logic before you just let somebody haphazardly change a value. So understand the concept of those and when you might need them. There's the static versus non-static stuff. Here's the idea of defining them versus using them. These two slides, very important. In fact, I might even ask questions that have you almost regurgitate these slides, but probably in such a way that you have to show me you actually understand what they're saying and not just you've memorized the words. The difference between defining methods and then using those methods. We call them a certain way depending on whether static or non-static. We define them a certain way depending on whether we want them to be used as static versus non-static. And kind of understand the concept of why. Kind of throwing back to, I think we used the example of the character class versus the string class in Java. Character class is filled up with a whole bunch of static methods so that when we use those, we have to call upon the character factory, if you will, and we throw it a char and it does what we asked it to do, converts to uppercase and gives it back. Those are a bunch of static methods, as opposed to the string class has 2 uppercase in it, but that's a non-static method, an instance method. So we use an instance of the string class and say, give us the uppercase version of this string, so on and so forth. All right, then we get into starting to talk about a specific example of creating objects and representing things with their, in terms of their attributes with fields. So you should be able to write a class with some number of fields and maybe an appropriate constructor and an appropriate setter and getter. So maybe I would ask a question kind of like, write a class for a player on a soccer team where you're keeping track of their name, age, and jersey number or something like that, and write the appropriate constructor and getters or something like that. So given that kind of information, you should be able to write that blueprint, the class itself. Like I said, I mean, the concept of inheritance, I guess, is fair game, but I'm not going to ask you to write anything with inheritance, but inherently, inheritance is built into object-oriented languages in that there's this top-level object that exists in those languages that everything then inherits from. So it could make it on there in some roundabout way, but not from let's use it in the wild perspective. So with that in mind, there won't be a heavy emphasis on protected. It'd be fair game for me, maybe in the question where I ask you to tell me what public, private, I might say also what protected is, be able to describe to me, when you would use those different things or what they mean. But there won't be a heavy emphasis on protected. Okay, I think that gets us everything. So any questions about the exam or any of that stuff? When is the, so I had told you last class that I'm going to put the exam up by, early Monday morning. So will be there and it'll be online. But you have to take it in a single sitting, but it doesn't have to be during the class time for the exam. You can do it anytime during the week as long as I have it in by 11:59 p.m. Friday, so I can grade it over the weekend. But I will. Does anybody know when the actual official time for the final exam is supposed to be? Tuesday, 10:10. Okay, so on Tuesday at 10:10 a.m., I'll log into Zoom. So if you would like to take the exam during that period of time, that 2-hour window, feel free to show up at 10:10 to take the exam then. If I show up and there's 0 people there after 10 minutes, I might just take off. But if you'd like to take the exam during that time period so you have access to me, I will make myself available during that time. Otherwise, you can do the exam whenever you want based on your schedule with your other exams and stuff, as long as I have it in by 11:59 p.m. on Friday. It is closed book, closed note. Don't do it in Teams. You don't have, no, we won't be in person. So, I mean, if you
Just in case if you want to go in person.
well, I mean, you could come here if you want, but I mean, I won't be sitting in the classroom. So I'll be on Zoom. So if you have a question, I'll be live. So I mean, I'll just be sitting there as if we're in person. And if you have a question, just ask me and I'll answer you. But yeah, so so I'll be live during the official time for the exam, but not necessarily in sitting in the room, because I fully expect there to not be very many people who are going to take it during that time. Students typically like the flexibility of figuring out where it fits with the rest of their exams and stuff, so it's works out. But I will make sure I'm there at that time on Zoom if you do want to take advantage of that. All right. Any other questions? Going once. Going twice. All right. So let's look at our homework. How'd it go? Pretty easy? Trivial? Spent 5 minutes on it? All right. So let's see. Add our player to the dungeon and continually ask them what direction they want to go and allow them to move around our dungeon so we can kind of see that we can traverse our map. Okie dokie. So let's go into this guy. All right. Let's run this real quick, make sure it still runs. As opposed to me having to refresh the screen. This. Well, the site loads pretty quick. Oh, there we go. Just took some extra coaxing. All right. So what do we have so far here? We have our 6 rooms we've created. We have our 10 exits we've created. We've associated those exits with all of our rooms. And then we've asked each room to display itself so we can see that our map was correctly put together. Okay. So now what we want, then at the end of class, I showed you, here's how you can get input from the user. So we want to now create a player, dump them into our game, and then ask us over and over and over again, where do we want to move? All right. And we want to display to the player the current room that they are in. All right. So let's start off here. All right, so let's go ahead and create our player. Player P is equal to new player. Is that what our player takes? Let's go look at our class. Class is a player. Player currently actually takes no parameters, but we're going to change that. Inhabitant is the guy that takes in a name and a number of hit points. The hit points is kind of unimportant here, but we'll go ahead and do this anyways. So we're going to say a player takes in a name. We will send that name to our parent's constructor. The parent is inhabitant. They'll go ahead and set the name equal to whatever was passed in and set the hit points into whatever was passed in. We don't really need hit points right now because we're not actually fighting. We're just moving around. So for the moment, let's just go ahead and just leave our hit points hard-coded that every player, he can have a unique name, but he gets 14 hit points. That's such as life. All right. So when we build the player, we're going to pass it a name. Okay. So there is my player right there. Inside of inhabitant, remember we had a display method. So let's go ahead and test this. We'll say e.display, which should say, hi, my name is Mike or whatever. Here's my, hi, my name is Mike. So we've successfully created a player. All right, so now we want to add a player to our world. Now we can get a little bit more formal than this, but we haven't really built a map class or something like that yet. So let's just work with this at the reasonably high level. So if I look at my map here, we see that really R1 is the starting point for our dungeon. Realistically, we might want to create like a dungeon object and put all these details that we currently have inside of that that dungeon object so that main looks a little bit cleaner. But for right now, we'll leave the wires a little bit exposed. So we need to have a way of getting a player into a room. All right, so we've now added the ability. So we'll go into room here and we see what is a room currently. Well, a room has its own name. It has its own description. It has a collection of exits. It keeps track of how many exits it has because not all rooms use up all the exits. So we need to know how many actual exits are in our, how many exits are actually in our room. Now we're going to need to keep track of another piece of information. We need to know about the player that's in the room. Right now in our dungeon for this assignment, we're going to assume that this is a single user game and we're not going to have multiple players in a room, although we can certainly do that. We're going to do it next semester. But for right now, every room has at most one player. Fair enough? So we'll say private player, we'll call this guy the player. When a room is first born, we'll say this dot the player is equal to null, which is its default value anyways, but I like to be explicit with it. So when a room first comes out of the oven, it has a field inside of it called the player that is meant to keep track of whatever player is in that room, including no player. So when we have a fresh room, the player, it is not inhabited by a player, okay? So now what we need to do is we need to build in the abilities to add a player to the room and also remove a player from the room. Because as we have our player going through our dungeon, right, we're initially going to add the player to the first room. And then if the player says, I want to go north, we're going to remove them from the current room and put them into the room to the north, so on and so forth, right? That way we don't run into a situation where we have the same player in multiple rooms, which computers let you do that, I guess, but whatever. Okay. So let's go ahead and write a method here. So this will be public void add player. This will take in a player P as a parameter, and we'll say this dot the player is equal to P. All right, that's how you add a player to the room. So if we just stop there for a second and we come back out here to driver and we created our player and we know that R1 is the very first room in our dungeon because we looked at our little map that we drew, we'll go ahead and say R1.addPlayer P. Okay, so now that guy is has been added to the room. Now, what we probably want to do is when a player first walks into a room, we could probably go ahead and have the room display itself to the player, something along those lines. So what we'll do here is inside of room, when a player is added, we will set this room's player equal to whatever player just walked in, let's say, and then we're going to say this dot display. We'll have that room display itself to the player, which means display it to our screen for right now. All right, let's see this work. So for right now, I'm going to go ahead and not display all of my rooms. Instead, we built up our rooms and exits. And then we're going to go ahead. I built my scanner. We're not using it yet, but I built my player. We added the player to the first room, which should then show that we're in the room and there's an exit to the north if we did get into our correct first room. And here's our room, room 1. Description of room 1. We were very, well, that's right. I was going to use ChatGPT to generate our room names. And so obvious exits. We have one to the north. Right now, I'm just displaying our player. We don't really need to do that. So once we're in that room, now we want to start going into this pattern of where we're going to ask the player over and over and over again, what do you want to do? Okay. So we'll go ahead and not have the player display itself. So we'll go ahead and write a loop where we ask the player enter a direction. We'll go ahead and read that direction in. I showed you that syntax at the end of class. So we'll go ahead and read the direction in. A good programming practice really would have been to define this variable beforehand and then set it equal to a value in here rather than appearing to redefine direction every single time through the loop. Modern compilers actually are smart enough to figure out what you meant and they won't redefine that variable over and over again. But good programming practice would be bring your variable into existence prior to using it. And then inside of our loop here, we're going to just set direction equal to whatever we read in, and we'll just update it each time through the loop. All right. So now we want to try to take a this direction. Now, if it's asking me for directions, I'm currently in a room with an exit that goes to the north, and I say the direction I want to go is LOL. That's not one of the legal directions, right? So we probably want to attempt to take an exit. And if it works, great. We'll remove them from this room. We'll put them into the next room. But if it doesn't work, then we probably want to spit out to them as, no exit in that direction or something like that. Then maybe tell the room to display itself again. All right. So inside of player, we're going to have a function, void. We're going to say try to take exit. And this guy will take in a string direction. All right. So now when we're inside a player here, what do we want to do? The player is trying to take an exit for the room they're currently in. Now, if I'm from a player's perspective here, do I know currently what room I'm in? I don't. So a player probably should be aware of the room they're in. A room should be aware of the player that's in there, but a player should also be aware of the room that they're sitting in, right? So we're going to add a field to player. We actually probably could add it to an inhabitant, since all inhabitants might be associated with a room. Pick your poison, I guess. Let's do that, I guess. You know what? Let's just do it in here. So, because I don't want to get too far into the inheritance stuff. So I'm going to go ahead and I'm going to say private current room. So when a player is first born, we'll set current room equal to null. Like I said, that's the default value anyways, but I like to be explicit. When a player first comes out of the oven, they're not in any room. They're sitting out there in limbo, okay? So now we need to have, since this is a private function, we need to be our private field. We need to be able to set the room we're currently in externally. So we need to create a setter for this guy. So we'll go ahead and say void set current room. This guy will take in a room R as a parameter, and we'll say this dot current room is equal to whatever was passed it. That makes sense? So now when we first put a player into a room, well, anytime a player gets put into a room, we want to update that player with the room they're currently in, right? So we want to call this set current room. So where does a player get put into a room? Right in here, where we add a player. Make sense? So when I'm adding a player to the room, we make the room aware of this player, but then we need to make the player aware of this room. Now, set current room requires me to pass a room in as a parameter. What room am I passing in as a parameter here?
Room 0.
Well, I'm inside a room here. What's room 0? Never heard of it. What's the scope of room 0? I assume you mean R0 from out here, but the scope of this guy lives and dies inside of driver's main, right? Right now, I'm inside a room. What room did I just put the player into? Generically. If I just added the player to this particular room, and then I want to let the player know about the room they were just added to, what room do I pass in right here? What is the name of this room? Super important concept, will be on the exam. Somebody knows the answer. I'd like to add him to the room I'm currently in, right? The room I just added the player to, I'd like to let the player know about that room. How does an object refer to itself from within itself? This. I am setting the player's current room to this instance of room. Make sense? Because it's this room that we're currently in that we're setting this player to. And when the player moves to the north, it'll be that room. All right? And that room's name from his perspective is this. And then if he goes to the north again, it'll be that room or that other room. And from his perspective, his room is called this. So this is how an object refers to itself from within itself, because we don't have access to variables like R0, R1, things like that. And we wouldn't want to hard code it in here anyways, even if we did have access to R0. For example, every single time we have a player get added to a room, we'll go ahead and add that player to the room, and then we'll just let the player know, yeah, you're in R0. No matter what room they just walked into, they're in this R0. All right, the guy's going to be pretty much, well, now he's got a separation because the room thinks he's one place and the player thinks he's someplace else. So we'll not let the player know about the room that they're currently in, which is this. All right. But we're only going to add a player to a room if we've already made sure that that room exists. Now, initially, when we first added this player, so down here, we created our player. We said room 1. It was room 1, right? Not R0. Yeah. Room 1, we want to add the player we just created to U. What does that guy do? Well, room 1 will set the player that's in there equal to the player that we just passed in. Then we'll let the player know about this particular room. So the player knows where he is in the world. And then we'll tell the room to display itself. All right, because we're inside the room class. This is how this room refers to itself from within itself while we're inside the class. Okay, but now as the player, we ask the player, where do you want to go? And the player says, okay, I want to go to the north. We need to try to take that exit. All right, because if we type in something that's not a legal exit, we're not going to be able to go there. So from a player's perspective, we're going to try to take an exit in this direction. So maybe what we do is we go ahead and we tell a, let's see. Let's build this into room. So we're actually going to pass the buck. All right. So inside of room, we're going to try to take an exit. Let's go ahead and have our player call this. So a player needs to ask the current room they're in to try to take the exit that they just read in. What's the name of their current room? It's called this.current room. This.current room dot try to take exit in that direction. All right. So the player tried to take an exit. And what did that mean from the player's perspective? He talked to his room and he said, hey, I want to try to take this exit, knowing that the room already knows about him because he's inside of the room class, inside of a variable called the player. So now inside of room, to try to take this exit, we want to loop through our selection of exits, right? And find out, is the exit I'm currently looking at, does it have the direction equal to the direction I'm trying to go? All right. So how many exits are in this particular room? This dot num exits, number of exits for this particular room. So I'll write a for loop. Print I is equal to 0. I is less than this dot num exits. I plus plus. Each time through, I want to ask a question. First of all, are you the exit that heads in that direction? Whatever direction I put in. All right. So we're going to ask, let's teach a exit how to tell us about its direction. So we already have a function called get direction. So we can ask an exit for its direction. So let's just use that. So the current exit we're looking at is this dot the exits at bucket I. And we want to get the direction associated with that guy. So that's going to be a string. That is the direction that this particular exit leads. We're going to ask the question, if that direction dot equals the direction we're trying to go, if that's a true statement, if the exit we're currently looking at has a direction that is equal to the direction we've said we want to go, we're in a good place, right? We want to go ahead and take the exit then. And what does taking the exit mean from a room's perspective? Well, I need to get the room associated with the exit. Exits have a destination. So just like I have a get direction, I'm going to have a public room get destination. And that is this variable right here. So I will return this dot get this dot destination rather. Called destination room. So actually, just for naming convention, I'll make my getter called get destination room. And that guy's going to get me the room that this guy leads to. So if I'm in this if statement, that means we have the exit that leads to the correct room. So we'll go ahead and say room destination is equal to this dot, the exits at bucket I dot get destination room. So now my variable destination, which is a room, holds on to the room that this exit leads to. All right. And it's that room that I want to put myself into. But before I can do that, I have to remove myself from the current room. I'm currently inside a room. Room keeps track of the player that's in there. What does it mean to remove myself from that? Well, this dot the player equals null. Poof, I'm gone. If the room were to look up and say, who's in here? He's going to see nothing. All right. Then I'm going to say destination dot add player. And I want to add the player that was currently in this room. But now we have a chicken or the egg problem. We just took the player out of this room. So we've lost control of our player. So we don't want to do this until after we've already copied that player over to the destination. This dot the player. So we'll take our destination room and we'll add the player, this dot the player, to that room. So for this exact moment, the player actually is in the current room and in that next room. Then we'll go ahead and remove the player from this room. So now the player is only in one place. All right. And then we'll go ahead and probably have that room display itself to the player. All right, reasonable enough. So we'll go ahead and we'll say, if we want to actually test this, what we can do is we'll go ahead and return. That'll make this function immediately end. So try to take exit, takes in a direction, returns nothing. It goes through, checks all my exits. Once it finds the exit with the direction I tried to take, if it finds the exit with the direction I'm trying to take, it'll find the room that leads to. It'll add the player to that room. It'll remove the player from this room, and then it tells this function to end. I'm not returning a value because this guy is void. Instead, I'm just saying, I'm done. I've done everything I'm going to do in here. Otherwise, if I never get into this if statement and this for loop runs to fruition, you could put a little comment here. We never found a compatible exit. So if we wanted to, we could do a little statement like system.out.println, no exit in that direction. Or if we really want to be no exit to the whatever direction was passed in. So I might say no exit to the LOL, something like that if I typed in bad directions. But this, we only get to this line if we have gone through every single exit we have access to and none of them match the direction we want to go. If that's the case, we will have not removed the player from this room. We will not have added them to any other room. We've just spit out that there isn't a direction in that, there isn't an exit in that direction. We never get to this line if we hit this return, because return makes a method immediately end. So when this is done, who called try to take exit? Our player called try to take exit. So after we try to take the exit, when we're in here, we don't know if we actually move to a room or not right now, right? Right now, we know the player is in a room. We're either in the room we used to be in, or we've been moved to a new room. So at this point, what will we do? We'll ask the room we're currently in, whatever room that is, to display itself. So this dot, what do I call it? Current room. Dot display. So after a player tries to take an exit, we'll ask the room to try to take the exit in that direction. It either accomplishes it or doesn't accomplish it. Maybe gives us a message saying there was no exit in that right way. And then we'll go ahead and just ask the current room we're in to display itself. Could be the room we used to be in, could be the new room. Any way you cut it, that's the room we're in right now. And we ask that room to display itself. So back out here to driver, enter a direction. We read in the direction. It is the player that tries to take an exit. Our player here, his name is P, so we'll say P dot, try to take exit in direction. And we know that that's going to attempt to take the exit in one way or another. It's going to show information to the player about the current room they're in. Right? So that's all we need to do inside this while loop. How long do we do this for? For right now, we could say forever. Maybe we do it until we say quit or something like that. If you wanted to have a way to exit out of things. But for right now, while true. Is that a Boolean expression? What's a Boolean expression? Any expression that boils down to a single value of true or false is true, always true, always true. That is the definition of a Boolean expression. It's just not one that changes. So this loop will go on forever. Now, does that mean we can never get out of this loop? No, we got some tricks up our sleeves, right? Like we could do return. Return would get us out of the loop. Return makes the function that you're currently in immediately end. What function are we currently in? Currently in main. When main ends, program's over. All programs begin and end with main. All right. But for right now, we're just going to allow ourselves to go wander around our dungeon. So forever, we'll ask for a direction. We'll read in the direction, and then we'll have the player try to take that direction. Who gave me an error? Oh, current room needs to have a type, doesn't it? I was testing you and you all failed. Killing me. I mean, that's 10% off the exam. All right, so we're currently in this room. We have an exit to the north. I'll go ahead and type in LOL, which we know is a bad thing. We see that we are still in room 1. So we tried to take the exit. We were unsuccessful. Now I'll go ahead and I'll type in north. So now we are in the next room where there's, we have to remember that when we added the player to the room, it displayed the room we were currently in. So if we go back out to room here, actually it's player, right? We try to take a room. We don't actually need to, we gotta stop this. We don't actually need the room to display itself after we've moved, because if we did successfully move into the room, then we are, the room will have displayed itself by putting us in that room. If you remember, room here has a, we add a player, it tells the room to display itself. That's why it displayed twice for us here. So let's go back here. All right, so we'll head to the north. So now we're in that room. We can head back south if we want. So now we're back in the original room. Let's go back to the north. Go to the north. So now we're in that center corridor where we can go north, south, east, west. We're right here. So if we go to the east, we're in room 5, where there's only a direction back to the west. We go to the west, there's only a direction back to the east. We go to the east, then we go to the north. Now we're in that top level room up here. We can go back to the south, and now we're in that center thing. We can go back to the south, go back to the south. Now we're in the first room. All right, so does that fulfill the assignment? All right, so now if we did want to put a way for us to bail out of here, we could, enter in quit here, and then inside of our code, just throw an if statement that says if they typed quit in for a direction, let's bail. But then you've also said you're not allowed to have a direction named quit, which is probably reasonable, but I mean, I've played some MUDs before that have some pretty funny directions, when you have to take portals or climb up or climb down, or there's a, magical something or other that I don't know if I've ever seen an exit called quit, but I never know. All right, so right now, if I do that, it's just going to say no exit to the quit. All right, so we'll stop our program by just saying stop. If I want to go in and put that little extra logic in here inside of driver, after I've read in my direction, I can say if direction dot equals, and here I'll just show you another function here, dot ignore case, just in case they type in quit in all caps or something like that. So if whatever direction they entered in from this line right here is equal to ignoring case, the word quit, then we maybe will do something like system.out.println goodbye, and then return, which makes whatever function we're currently in end. And we're currently in main, which means the program's over. There is another keyword we could use here called break. So what I could do is I can break, and breaks us out of the most local loop. And then right after that loop, I can put in goodbye. So we can just say, whenever we escape this infinite loop, that means we're done with our program. We'll say goodbye here. So if the direction they typed in was quit, I'm going to just break, which breaks us out of the most local loop. So we'll jump over this guy right here, getting out of the this loop, and then we'll print out goodbye. So now I should be able to wander around and eventually say quit. So here we'll go to the north, go back to the south, we'll type in quit, and there's our goodbye. All right, questions about any of that? Let me grab this link here. Say final dungeon crawler right there. All right, so now if we just kind of a preview in our last couple minutes, so when we start up in January for the next class, we're going to pick up right where we left off here. We're going to add a little bit more functionality to this in Java, enough to really, I probably won't add tons more functionality to this in terms of a full fighting MUD or something like that. But I at least want to maybe add maybe put monsters in there, or something like that, and then maybe have them fight each other until hit points go down to 0. Don't get too fancy with it. But I really want to introduce the concept of threads. Okay, so multi-threading is kind of our magic in modern computing, where we can have multiple things seem to happen at the same time in a non-blocking way. That means, for instance, right now, for example, if I run this program, right now it's asking me for a direction, right? Was I not in main? I was in Maine. All right. So right now, this program is doing something that we would call blocking. It's waiting for me to type something in and press enter. I might type it in 5 seconds. I might type it in a year. I may never type it in. So as far as the program is concerned right now, nothing else, no other logic can happen inside of our code as long as we're sitting here waiting for users' input. With threads, we could have a thread be sitting here waiting for user input while the program is off still doing other things, maybe monsters or wandering around our map, something like that, because that's always fun when you have like a rat wander in a room and they're super aggressive. They immediately pounce and they're waiting for you to type in your direction. All of a sudden you get knocked off your course like, oh, I can't go to the east. I'm in the middle of a fight. Snooze, you lose. All right, so we'll talk about threads. And the reason for that I want to do threads in Java is to show you what's happening behind the scenes, because then we're going to jump into Unity. So if you wanted to, you could start messing around with Unity over break. There's a really good tutorial if you wanted something to play with in Unity just to kind of get some skills under your feet. I'm not going to assume you did this, but if you wanted to do it, that's a really good tutorial for Unity. It's not super, super long, but it shows you a lot of the basics, because Unity has something called the game loop, which effectively is something that's happening in the background over and over and over again. It's a multi-threaded model. All right. All right. Well, I will see you when I see you. Good luck with your exams next week. Remember, I will be on Zoom at 10 a.m. on Tuesday. Otherwise, have a safe break, blah, blah, blah. I'll see you, whatever, January 8th or something like that, whatever that Monday is.
This break's a lot shorter than it was last year.
It's